Okay, good morning. Our project is about the EAU Smart Filter. My name is Paula Gomez.
Donald Curry.
Donald Curry. So we first we will speak about water, emergent property about water. Sorry. Okay. Water is essential for our body, so we use water to drink, water to cook, to wash our hands, and it's more or less it's very important for our life. So as we study in biology class, we can show in these pictures some emergent property about water. Water is primarily of life, so water helps serve life in our body. So it helps chemical metabolism in our body. So if we eat something, it will help in the digestion, transport nutrients, and remove waste of our urine, and regulate temperature of the body. So so water is so important for our bodies. In the evolution of the human beings, we can see some contaminations of water, and it will make our project. Our project are the solution of this problem. And in this time, we will talk about contamination with arsenic in water. In these slides, we can see the location of arsenic in water. In the orange slides, we can show the most highest underground water contamination. So if on the earth, water arsenic is on the earth. So in South America, Chile and Argentina, which is my country, has a lot of arsenic in air. Bangladesh and India and Nepal, it has also have the same problem. In North America, we have on the northwest side, not too much problem, but also have arsenic in groundwater. The allowed percentage of water is 10 parts per billion. It will depend that how long of water are you taking of these contamination types. So it's a huge problem in our life. The effects of arsenic on our body is we have skin we can have a skin cancer, nervous system, affect the nervous systems, cardiovascular system. In kids decrease the mortality, and so in Bangladesh it's a huge problem because the people doesn't have the money or the conditions to filter their water. So in Argentina too. So the filter would be about the 1 nanoparticle. Will be like a membrane. Yeah. Okay. Will be like a membrane that will separate the effluents. That will be in this case arsenic, and will be able to flow the clean water about this membrane. So if the nanoparticles are smaller than usual particles, so the surface of the contact with water and the membrane will be able to separate this hard arsenic composition, and will be so we are be able to have clean water to consume. So with this technology, we'll be able to be the solution of this problem.
So the EAU Smart Filter would be the third addition to two filters of water that are currently available to consumers today. The first being the Steripin, which is like an injection that goes in water to purify it, and the second being a life straw, which is another personal item that will purify the water that you consume from a body of water. But the difference between these two and the EAU Smart Filter is that the EAU Smart Filter can filter water for personal use, but the main use is for it to be able to send reports about the state of arsenic contaminated water regularly to the user. So basically the use of the EAU Smart Filter is to gather data over a long period of time so that scientists or even consumers could find a better way to solve the issue within bodies of water rather than to just keep purifying it for itself. The problem might be able to be solved for a large population. It's just the same thing I just said. Rather than instant filtration of pure water, the EAU Smart Filter can purify water instantly, but like I said, its main use is for the long term. So it's a really simple concept process. You drop the filter into your source of water, it buoy sends it to the bottom, and you can make it so that through the app you get reports of the state of the water, specifically arsenic contaminated water, at an hourly rate, at a daily rate, or a weekly rate. You're notified the volume of the water arsenic in contrast to water. Another goal that we have for this, aside from an intuitive design, is for it to be completely open source. So we plan on using parts that can be bought and used in an Arduino, along with sensors that can be bought from the internet, such as the Panasonic PRA4602 sensor. We want this to be completely buildable by common people, but still be accessible and intuitive in regards to scientific research. Not only will we be open source, but like I said, it will have many differences when compared to things that are already out in regards to water filtration. So while it's commercially available like other things, users will also be able to become involved with it on their own, whether they're normal people or scientists. So it'll bring another level of depth into the water filtration issue by allowing people and scientists to become involved in it. That's it.
All right, open for questions now. We have how much left for questions?
It went off at 5 minutes, I didn't have time for questions.
Okay, well, we just got two minutes after 5 minutes for
Okay.
questions.
Okay.
So, questions?
What were your names again?
Donald and Paula, Donald Curry and Paula
Gomez.
Gomez.
Had questions?
So how would this device work on a personal level? Is it like the straw, or is it like something we pour through? Or?
Yes, so we haven't made a design yet, but the way that it would work on a personal level is it would be handheld, but like I said, you would be able to bring it out of a body of water in order to test the water yourself. But if you were to bring it out of the water, you would pour the water in there and it would filter it for you, similar to a sink faucet purification module. But like I said, its primary use would be to stay in that source of water in order for you to get long-term testing.
How is it able to read your arsenic levels?
So, go ahead.
There is colorimetry chemical technique. So when higher levels of arsenic are in water, they are more difficult to take up. So with this type of colorimetry, you are able to see how arsenic or how.
And then it has a sensor that actually sends that reading to your phone.
Yeah.
Pretty good. Good to me.
Any other questions?